Good afternoon, ladies and gentlemen. Enda Nolan's my name, Director of Coastway. Here to talk to you today, laser scan to modelling. Specific job we're talking about is the Qasr Al Hassan. It's the council chamber headquarters, shall we say, of Abu Dhabi. How we came across this project, we had been out there on a business development project when we got a call from the client who had a planning problem. He needed the scanning and modelling done pretty rapidly. We were able to get together, we put a team together ourselves in third dimension. He needed some nice visuals and so on. And we were able to get together and mobilise in 2 days. The project took, I'd say in total, from scanning to modelling, about less than 2 weeks. Before I continue, I think we're going to show you a bit of a video just so you get a feel of what the project was about. Hear that. Okay, so you'll get a feel for the project. You'll notice in the council chambers there's no air conditioning. Probably a good idea because politics gets done very quick. We should probably do the same here and have no heating down the Dáil. But we'll move on now to, you get a feel. We'll run it again. The piece of kit we use is actually, I'm not here to, shall we say, demonstrate it, and most of you will know by now what laser scanning is, but that's the piece of kit we used over there. Very handy. We mobilised, we threw that in the suitcase and off we went, and we had no problem getting through customs and so on. It can be a bit of a problem at times. The name of the project is Qasr Al Hassan. It's the Cultural and Heritage Quarter in Abu Dhabi, and it was a joint venture between ourselves and Third Dimension. Now Nick will actually get up in a few minutes and talk through the images and the virtualization that we've actually done. That's a look at where we were. That's an ancient fort. As you can see, shall we say, there's a lot of encroachment on it. The building, shall we say, you won't see it from there, but you'll see it in a second. There's a lot of building going around the side at the Abu Dhabi. The government, they want to, shall we say, use every last piece of space because there's, shall we say, a need for office development and so on in it. So I told you about the client. We deployed within 2 days and commenced work on the 3rd. The laser, we carried the Faro Focus on board, and must say it performed very well. At times, shall we say, we were scanning in 50 degrees. The project took in total 4 days to complete on site. The registration took 2 days. We were actually registering the data while we were over there and shipping it back. The guys were working on the model. In total then I'd say it took, actually less, it took 9 days. The client was able to view their registered point cloud while we were still on site. So if he needed more done in any area, we just added to it. We took a total of, I think, 70 high definition scans, 11 rooms. The main chamber was closed for the few days we were there, and we provided Gecko Engineering, who were the appointed client's rep. The client viewed the point cloud data, as I said, as we were modelling. Well, shall we say, it was combined. They needed this as they had forgot about planning, shall we say. They needed to show the government, shall we say, what they were doing. As you'll see, that's the inside of the main chamber. It was vacated while we were doing the work. There's a lot of reflective marble, reflective material. So, shall we say, we've done quite a lot of scanning, quite a lot of cleaning up of the point cloud. That's a point cloud image of the main entrance to the chamber. We'll say that the quality of the scanner we were using was very good. On the back of what we've done and what the guys provided, we've been asked to, this is stage 2 of the project, that's the mosque in the southwest corner. The guys are deploying today and heading over, I think tomorrow. This mosque here will be laser scanned thoroughly and will be demolished brick by brick and replaced, shall we say, reconstructed somewhere else, as that bit of land there, shall we say, will be redeveloped. I'm going to hand over now, I think, to Nick. Nick's going to stand up and give you a talk on the visualizations of it. I'll hand over to Nick. Cheers.
Afternoon, guys. Long day, so we're at the tail end of it. Apologies for the growth on the face. We're doing a bit of Movember in the studio, so I grew a bit of a beard with it to disguise it a little bit. What I want to just talk to you about very briefly is the process, the 3D modeling process from the actual laser scan. So once we get the data, taking the data up to a proper working 3D model in order to create the design, hand it on to other disciplines such as structural MEP. Just to give you a little very brief background as to who I am and who Third Dimension are, and why we've positioned the importance we see on BIM. Traditionally, for the past 13 years, we were architectural visualization, only architectural visualization. But after doing a lot of research and with a lot of noise about the BIM over the last year, in particular in this country, we've transferred our architectural visualization studio into a full 3D design bureau, and one of the departments is BIM. Okay, so we're taking 5 services in our BIM. We're taking CAD to BIM, building components to BIM, which is going to be very big, FF&E to BIM, BIM 3D visualization, and of course then laser scan to BIM. So that's how we've sort of positioned ourselves within the BIM arena. What I just want to talk to you about here is actually from obviously the field to BIM, just to touch on the indexing and evaluation of the point cloud and the importance of that. The 3D modeling process, and especially from point cloud data, how important it is in particular for accuracy. What we've learned to date through this process, maybe some of the little pitfalls and the deliverables that clients should expect from a laser scan to BIM project, and then we'll field any questions that you may have. Okay, so indexing and evaluation. It's really important once we get the point cloud to take a tour around it. In particular on this project, we didn't go out to Abu Dhabi. We partnered with Coastway, but we weren't going to take the trip out just to watch the scanning process. So what the index and evaluation does, it allows us, before we actually even start the modeling process, is to take a tour through the actual the building itself and get a good idea of what the building is, any sort of issues there may be when it comes to the modeling process. So we're saving time and money when it comes to the actual modeling process. So even taking a couple of hours walking through the actual point cloud, understanding the building and how it works, will save a lot of time on the modeling side. So we use Autodesk Recap to analyze the point cloud, and we've already noticed that with 2014, what you call Recap is far better quality. So we use it to check for errors that may have happened at the registration stage, which is more than unlikely, but also then to check for any shadows in the scan. So if there's parts of the model that were missed or without being able to gain access to, which we've experienced, that we can't model and then have to make an assumption within the model. Evaluate the point cloud density, and this is really important. So, and it was on this project, what we did was we asked Coastway to keep the file size down once they sent it over to us. But then when we evaluated it, we realised that we needed a denser quality. And the beauty about the laser scanning, what Coastway did was we could go straight back to them and say, listen, point cloud is not dense enough in order to get us to an acceptable tolerance. So you need to give us a higher density point cloud, which they did straight away. And then it's also, making that call between working with a very dense point cloud that can sometimes work out, if you're working on a very large project, that can work out that it's the file size is not workable. And then the indexing process is bringing it straight into Revit native format. PCG in Revit 2013, and now with 2014 Revit, which we haven't yet upgraded to, but we've been researching, then is just bringing straight in from Recap. And then 2014 point cloud superior to 2003. It's a better point cloud engine in terms of indexing, the speed and quality. Indexing point cloud, if you've got a huge point cloud, indexing it into the software program like Revit can be quite time consuming. And that's one reason why taking a tour around it in something like Recap is really important, because you don't want to index it and then go to your modeling and find that there's issues, and then you have to go back out and start and to re-index it. So the 3D modeling of the as-built, we use, as I said, Autodesk Revit 2013 to create our BIM models. The brief we were given on this project was obviously create a detailed BIM model in order for the redesign of the 3 areas that were scanned. Modeled to real-world coordinates to allow for coordinated with other disciplines, which everyone knows about in terms of handing the model over to structural and MEP. The tolerance is really important when it comes to laser scan. Acceptable tolerances on the modeling side will be 10 to 15 mil, maybe 20 mil for uneven surfaces. We're recently looking at we got a guidelines from a surveying company recently in the UK who actually say plus or minus 20 mil for modeling, but we'll always model to a 10 mil tolerance, and it's important to model to as close to 0 as possible, even though it's obviously not possible all the time. Another important thing in the modeling here, and it was touched on in the previous presentation, was the amount of bespoke modeling that goes into laser scan to modeling. You really need to know how to model. You cannot use, as the previous speaker spoke about, families from Revit. It's all bespoke modeling. I think the only families we used in this were the doors. Everything else was bespoke. So you really need to be on your game in terms of laser scan, because laser scan, obviously, as the as-built, it's not the ideal design scenario. And then another really important thing, both to cover ourselves mainly and also to help the process when the model is handed over to, say, structural MEP, is that a model report is handed with the actual model. So stating assumptions that we may have had to make during the modeling process or discrepancies we may have found, or statements. So that's a really important piece of documentation, and anyone that is doing laser scan to BIM modeling should be issuing a model report with it, because what happens invariably, someone goes and checks the model, they start saying, well, there's an issue with the model here, it's not how we sort of see it on site, and we always then go, just refer to the model document, point whatever, and it has addressed that point. So the deliverables we deliver on a typical project, and on this project, the actual Revit model then, 3D CAD model as well, once we clean up the model, we'll issue standard 2D plan sections and elevations. And as everyone knows, with the BIM model, the major advantage is taking sections, plans and elevations from any point within the model. DWF models, so for clients who may not be using Revit, handing over a DWF model in order for them to view it on, say, something like the free viewer, Autodesk free viewer, is advantageous. And then, as I mentioned before, the model report. 3D PDF, another way, like the DWF model, in order to show to clients the actual, the model itself, the building, and being able to take sections through it with the PDF, 3D PDF. Sorry. And then taking it to 3D photorealistic visualization. And this is where our experience of architectural visualization comes into it. So from a presentation point of view, or right through to design, planning and marketing, being able to take this and not just have your standard screen grabs or standard rendering within Revit, it's actually taking it to a photorealistic finish and walkthroughs. So the process summary, basically scanning and point cloud generation, point cloud registration after that, which can happen on the field, as Enda spoke about. So modelling can actually begin before the surveyor actually comes back from site. The point cloud indexing and analysis, and how important that is before the actual 3D modelling process begins. Model documentation, and with the model documentation, it's a case of documenting as you go and not waiting until the end, because the importance of that document, it's paramount in the actual process. The model optimization and review, then, it's obviously cleaning up the model to give a clean model to the client at the end of the day from what we've worked on. And the 3D visualization from external software, so bringing it out of Revit and bringing it into our third-party software like Autodesk 3D Studio Max, which we do. I know with 2014, there's a lot more compatibility between the two, bringing from Revit straight over to 3D Studio Max. At the moment, we're working off two different versions, but it's a very small workaround at the moment, exporting from Revit and bringing it into Max. So what we've learned from the process, software improvements obviously coming down the track, and that's going to continue, I think, as the years go on, and it's been talked about an awful lot here. There's a lot of jostling going on at the moment between all the different software providers as to what is the best software, and I think once the software companies realise that they're never going to get everyone working on one software package, and that they need to somewhat meet in the middle, which they are kind of doing, but there's still, I think, as the previous speaker spoke about, in terms of IFC, and there can be sometimes problems going from, say, ArchiCAD to Revit. Point cloud density, you know, balancing, it's that balancing act of making it too dense and not workable, to making it too fine, and then not being able to model to 10 to 15 mil accuracy. Tolerances. The tolerances when we're working with the as-built environment are crucial. There was a project we worked on, again, with Coastway recently, and one of the issues was about accuracy within the model itself. We were adamant about the actual accuracy from the point cloud, and we were proven right. We sat down with the client, and then once the site was walked after it was laser scanned, it was realised that the model was actually correct. But the tolerances are very important, and bringing it on to obviously model accuracy, which is obviously fundamental for other disciplines, for the designer and obviously the end user. Scanning, one of the things that, you know, Coastway do very well is they over-scan in a way. So what we mean by that is we can never have too much data of a room or of a building. It's much better having more data than having to make assumptions. So it's about over-scanning, making sure we have enough, combined with then photographic information to make sure it's when it comes to the modelling process, that we don't have to make assumptions. And then the importance, as I touched on before, about the documentation. So then basically taken from your point cloud to Revit to your 3D visualization. Issuing the 3D visualization along with the actual Revit model then allows the client to pitch this as a new art gallery, but then actually have the functioning model in order to go ahead and design it. So more than happy to take any questions, myself and Enda, and thanks a million for listening. Cheers.